We are finishing 6-4 today. So yesterday was all about rhombuses. Last night's homework, the one we just spent some time going over, that was all about rhombuses. Okay. Now we're going to look at the other two pieces of section 6.4. Mm-hmm. The first one's a rectangle. Then we'll talk about a square. So a rectangle is a parallelogram. So all those things we know about parallelograms are still true. What makes a rectangle special is that it has 4 right angles. So you can go ahead and label these. So a square is where a rectangle and a rhombus come together. Yeah. So a square has all the properties of both. So it has the 4 right angles of a rectangle, and it has the 4 congruent sides of a rhombus. Okay? So you can mark these guys and these guys. So every square is both a rectangle and a rhombus. But every rectangle isn't a square, every rhombus isn't a square. But every square is both. Okay? Any questions? All right, so here are some properties of rectangles and squares. So since they're all parallelograms, all the parallelogram properties are still true. Okay, so all the five, there are 6. Still have, that's weird, still have these 5 properties, and then there's a list of 6 properties. Whatever, 6, 5, same thing. Not the same thing. But the properties on the board hold true for rectangles and squares because they're parallelograms. So we're basically just getting like more specific. All of the properties that we learned last week are still true for rhombuses, still true for rectangles, still true for squares. So the opposite sides are parallel, the opposite sides are congruent, the opposite angles are congruent, the consecutive angles are supplementary, alternate interior angles are congruent when you add in your diagonals. The diagonals bisect each other. Here are the new properties that are unique for rectangles and squares. So I'll give you some time to get this information down. Like we talked about, in a rectangle, all 4 angles are right angles. Mm-hmm. And then number 8 is really important for a rectangle. The diagonals are congruent to each other. So they still bisect each other and they're congruent to one another.
Oh my God.
Now, in a square, since a square is a rectangle, all of the special properties of a rectangle are true. All the special properties of a rhombus are true. So I know all 4 sides are congruent. Diagonals are perpendicular. Those 2 rules are from yesterday. Corner angles bisect, still true from yesterday. And then 10 and 11 are straight from the rectangle one. So even if you want to just maybe like put an arrow over, you don't have to write it twice. So the square has a lot of interesting things going on. So yesterday we stopped at 6. That's why we're just jumping right into 7 right now. So this says that we are going to find the value of the variable for this rectangle. So what do I know about opposite sides of a rectangle? Congruent. The opposite sides are congruent just like any other parallelogram. So how am I going to find x?
X plus 15 equals...
X plus 2...
equals 5.
No. Opposite sides, not consecutive sides. Opposite sides. So x plus 2 equals 8. X equals 6. Good. Questions on this one?
Nope.
No. Why every time can we do this simple?
All right. So in a square, what do I know about the diagonals? They bisect each other. That's true. But I'm trying to find some information about the angles. So as far as the angles go, what do I know about the diagonals? Think about the rhombus. Remember, a square is a rhombus.
90.
Yes. So these are all 90. Okay. Now, we also learned that all of these angles are 90 degrees in a square, right? And in any rhombus, we learned that the diagonals also bisect the corner angles. So if each one of these is 90, and then we slice it in half, they would all be 45. So we can fill in all these angles.
Which one is this for?
The whole angle is 90 degrees since it's a square. And since a square is also a rhombus, they're also bisected. So if you cut 90 degrees in half, you get 45.
Okay, so which problem is this one?
This is number 8. I'm just doing your notes with you.
Oh, okay.
Your notes packet is literally just on the board now.
Each other down.
Okay. Now, angle ABE, 45 degrees. Angle CAD, 45 degrees. Angle CED, 90 degrees. Angle AED, 90 degrees. These angles are true for all squares, okay? All squares, please stop. All squares have perpendicular lines in the middle. The diagonals are perpendicular. These angles are all 90. They're all bisected to make 45-degree angles when you add the diagonals, okay?
Yeah.
So this is a pretty standard question for squares.
Not really.
Are we good?
Yeah. Ouch.
Let's try to fill in all the missing pieces. These angles are not perpendicular because it's not a rhombus and it's not a square, okay? So don't automatically go marking them all 90, especially since one of them was already given to you as not a 90-degree angle. Right here, we have a 50-degree angle, which gives us the opposite interior angle, which is 50 degrees. Since it's a rectangle, do we know what this other angle is down here?
Triangle.
50?
90. A triangle. 60.
25?
Yes, so this one's going to be 40 degrees. Because that's 90 degrees.
Right, okay, I get you. I got you now.
We have a 90 and a 90, right? In a rectangle, every angle is 90 degrees. That's what makes it a rectangle. Okay? All right, so if this guy's 100, we have vertical angles here. This guy's 100. Everybody still with me? Okay, now we can work with what we know about these guys right here, right? That's a linear pair. So if that's 100, then we have an 80 over here and an 80 over here. It's kind of hard to read mine. These little guys are 80 and 80. Okay? So focus in on one of the triangles. I'm going to go with the bottom one first. If we have a 40-degree angle and a 100-degree angle, and I'm looking for that last angle, I can subtract. That would be 40 degrees. Okay, so this guy's 40. That means this guy's 40. And then you can do the 90 minus trick again. So you get a 50 and a 50. So a lot of repeating angles going on here. Okay? Let's see if we can answer the actual questions. So JKN, that's a 40. NLK, that's a 50. MNL, that's a 100. And J, N, M, that's an 80. All right, I'm going to switch us back over to the PowerPoint so we can do number 10. Look, compare your notes to mine. I think the 14 is what's missing. So what do I know about the diagonals of a square?
They got 90-degree angles and all sides are the same.
Okay.
All sides are congruent and diagonal.
Same thing as the same.
The diagonals are what?
Idiot.
The same.
They're perpendicular. They bisect each other. They're also congruent to one another. The whole diagonal going this way is congruent to the whole diagonal going this way, just like in a rectangle. Okay?
Yes.
So I'm going to set those equal, and I'm going to solve for the x. All right? So we are going to get that x equals 2 here. All right, we're going to do 11 and 12 sort of rapid speed. So get ready. Buckle up. Okay, if we're looking at a square, what do I know about every angle in a square?
And 90 degrees.
90 degrees. So set that equal to 90. Add 9.
99.
Divide by 11. And x does equal 9. Good. So remember, squares and rectangles, those angles are 90 degrees. So if they give you an expression and everything else is missing, you got to remember back to that 90 rule. Okay? All right. Number 12. What do I know about the diagonals of a rectangle? As far as their length. I know they're perpendicular. That's not helpful. They bisect each other. So if this is 6, how long is this guy over here? 6. So the whole thing is 12. They're also congruent. So what's this whole diagonal? 12. The whole thing would be 12. So you got 2 rules going on. They bisect each other. So 6 and 6. So the whole thing here, CE, would be 12, which means that CD is also 12. That's what they're calling us X, so X is 12. All right. Your notes end after 12, right? So we are good to go. I'm going to pass out your homework now.